Calculus BC, our second video. We're finishing lesson 4.9, the last lesson in our chapter, and we're talking about antiderivatives. So take a look with me at number 5. Find the position function if the acceleration function a of t is equal to 2 minus 6t, while the velocity at time 0 is negative 5, and the position at time 0 is 4. Well, if I know that my acceleration is 2 minus 6t, I could take an antiderivative with respect to t. The antiderivative of 2 would be 2t. Then, of course, here, the 6t, I'm going to bump that up to a power of 2 and divide by 2, and I'm going to have a constant. Now, my velocity is 2t minus 3t squared plus some constant. You could definitely check if you've done this correctly by taking a quick derivative. But look, we have an initial condition, v of 0 equals negative 5, meaning the velocity itself is negative 5 when your time is 0. And t equaling 0 is going to cancel that out. You'll have c is equal to negative 5. What does that really mean? Or c1, I could call that. It means that your velocity is 2t minus 3t squared minus 5. So at this point, this is great. We now have a velocity function. We'd actually like to move on and find our position function. So I'm going to do one more antiderivative. I'm going to bump this power up, the t to the first, up to a 2 and divide by 2. I'm going to take this power of 2, bump it up to a 3 and divide by 3. This is a 5, so the antiderivative of 5 is just 5t. And then look at this, I'll have a second constant. And of course, as we're working this out, these 2's are going to cancel. We'll have t squared. This is going to wipe out. You'll just have t to the third. Here's minus 5t plus this constant. So, as we're looking at our position function, of course, you can see that we also are told that s of 0 is equal to 4. So the position coordinate will be 4. At time is equal to 0. By the way, they don't have to give you time of 0. That's so important. I think Stewart is going to give you some occasional problems where it might be time of 1 or something like that. So you might have to do a little extra work, and that's fine. But at this point, guys, you know what that constant is. That C2 is positive 4. So tell you what, I'm going to rewrite my position function now, and I'm going to go in descending exponential order. Negative t cubed plus t squared minus 5t plus 4. Could have gone in ascending order also, but that's really what we've got. One last follow-up question. Is the particle speeding up or slowing down at t equals 1? Well, acceleration was 2 minus 6t, and velocity we just found was up here, this 2t minus 3t squared minus 5. If I were to plug in a 1, I'd have 2 minus 6 times 1, that's 2 minus 6, which is negative 4. If I were to plug in a 1 for my velocity, I'd have 2 times 1 minus 3 times 1 minus 5. And that's 2 minus 3, which is negative 5. Minus 5, of course, is negative 10. Well, I'm sorry, 2 minus 3, pardon me, is negative 1. And negative 1 minus 5, correcting myself, that's negative 6. Pardon me. Well, at this point, regardless, though, I think you can see that velocity and acceleration are both negative. So the particle is speeding up, And the reason that you'd give, it's speeding up because v of 1 is negative and a of 1 is negative also. And that wraps up chapter 4.